Training and evaluating models. Now, training and evaluating models involve a series of steps, including preparing data, defining the models, compiling it, training with the training dataset, and evaluating its performance with validation or test data. Let's explore these 7 steps in more detail. The first step, data preparation. Before training a model, you need to prepare your data. This involves loading, pre-processing, and splitting the dataset into training, validation, and test sets. Let's look at an image classification example. In here, I'm importing the MNIST from TensorFlow Keras datasets. I'm importing 2 categorical from the Keras utilities, and I'm importing train test split from the model selection from sklearn. Now we load and pre-process the MNIST dataset. So for that, we say xtrain, ytrain, then use the xtest, ytest equal to mnist.load data. To xtrain, we pass xtrain.reshape by passing the variables of -1, 28, 28 by 1, and as type of float 32 and divide that by 255. Next xtest, we pass the reshape with -1, 28, 28, 1 as type of float 32 and divide that by 255. Next, we give ytrain to categorically ytrain and with the parameter of 10, and then ytest to categorically with ytest with a parameter of 10. Now split the data into training and validation sets by calling xtrain, xval, ytrain, yval, and then train the test split, call the train test split function and pass it the xtrain values from above, ytrain test size of 0.2 and random state of 42. Second step is defining the model. Now define the architecture of your neural network using Keras layer. This includes specifying the input layer, hidden layers, and the output layers. One of the examples that I've built here is first import the sequential from Keras. Next is con2D, max pooling 2D, flatten and dense from the layers. And then you can define a simple convolutional neural network by calling the sequential function and passing it that con2D of 32 kernel size, 3 by 3 activation of ReLU and input shape of 28, 28, 1, max pooling 2D pool of 2 by 2, flatten that, and then dense 128 of activation ReLU and dense 10 of activation softmax. Next step is compiling the model. Compile the model by specifying the optimizer, loss function, and metrics to be used during training. Here's the example. So compile, you pass the optimizer of Adam, you pass the loss function of categorical cross entropy, and you pass the metrics of accuracy. Then next, train the model. Train the model using the training data and optionally a validation data set. Specify the number of epochs and batch size example. So in this case, if you look at the history, equal to model.fit xtrain, ytrain, epochs of 10, batch size of 32, validation data xval, yval. Fifth step is to evaluate the model. Evaluate the model performance on a separate test dataset or validation data to assess its accuracy and generalization. Example is here where we pass test loss, test accuracy is model.evaluate xtest and ytest, and print the test loss and print the test accuracy. Sixth step is to visualize training history. In this, you can visualize the training history including loss and accuracy over epochs using the information collected during training. Here is an example where I can use the PLT from the matplotlib pyplot visualization tool. Plotting this particular training history, you use the PLT which we defined above and pass call the plot function and pass history.history loss and label of training loss. Then plot history.history value loss and label. So you're plotting the training history across different axes and passing x label, y label for epoch and loss, and creating the legend using the legend function and plot the entire data into this plot.show function. Next step is making predictions. Once the model is trained, you can use it to make prediction on new data. Here's an example where you can say predictions equal to model predict and pass the new data to it, and it will make the predictions for you. Training and evaluating models involve a sequence of well-defined steps from data preparation to model definition, compilation, training, evaluation, and visualization. By following these steps, you can efficiently build, train, and assess the performance of neural networks for various machine learning tasks. Experiment with different architectures, hyperparameters, and training strategies to optimize the model's performance on your specific problem.